Look at this example. Prove that if y equals to x sine x, then x squared d squared y dx squared minus 2x dy all over dx plus all in bracket 2 plus x squared close bracket y equals to 0. What they want you to do is, since the right hand side is equals to 0, prove to show that the left hand side too is equals to 0. We now write solution. You know, this is the function given. Y equals to x sine x. It implies that we are going to differentiate this function twice and substitute into this equation, this differential equation. This is a second order differential equation. So we are going to differentiate this function twice. Okay, let us differentiate this function. We know that we have two functions here, x sine x. Ordinarily, we can use product rule to solve this function, but that one will take our time. So we are just going to use normal method to differentiate this function. Okay, note that dy all over dx is the same thing as y prime. Amen. This is equals to, we are going to hold sine x constant, then differentiate this x. It means we will hold sine x constant, then we differentiate x. If we differentiate x, we will have 1, then we use 1 to multiply sine x, it will give us sine x. Amen. Okay, so this will give us sine x plus, we will hold x constant. We will hold x constant. It means we will differentiate sine x. If we differentiate sine x, it means we are going to have cos x. So if we use cos x to multiply x, it will give us x cos x. You agree with me? Okay? So here will be x cos x. Amen? That is our first derivative. It implies that our dy all over dx, or which is equals to the same thing as y prime equals to sine x plus x cos x. Okay, you know that this equation is up to second order. It implies that you are still going to differentiate this first derivative with respect to x. Amen. So it implies that we are going to differentiate this function. D, it means we are going to have d squared y all over dx squared, which is the same thing as y prime prime, is equals to, we know that here we will differentiate sine x. If we differentiate sine x, it will give us cos x. Amen. Then here we have two functions. We are going to differentiate one after another. Okay? So if we hold cos x constant, if we differentiate x, it means we are going to have 1. Then use the 1 to multiply the constant, which is what? The cos x. It means we are going to have plus cos x. Amen. Plus cos x. Okay? Then we are going to hold x constant, then differentiate cos x. Any value we arrive at, we use to multiply the constant, which is x. So if we differentiate cos x, it will give us minus sine x. So minus sine x times x, it will give us minus x sine x. Amen? So it means we are going to stop here. Then we will substitute in this value, this guy and this guy, into this differential equation. How? Let's do it together. Amen? Okay? Let's do it together. It implies that here, d square y all over the s square, we are going to substitute in this. Are you following? Okay, let's do it here. We have here x square, amen? X square. So if you agree with me, we'll write x square all in brackets. Instead of this, we'll write down this cos x plus cos x. But note that if you can see what I am saying, note that this is the same. Now we can add cos x and cos x together to give us 2 cos x minus x sine x. Amen? It implies that our y prime is equal to this. This is the same as this. Is that clear? So now, instead of this, we will write 2 cos x minus sine x here. 2 cos x minus x sine x. Amen? Close bracket. Then what do we have here? Minus 2x. And our first derivative is this. Okay, we write minus 2x, open brackets. Our first derivative is sine x plus x cos x. So we write sine x plus x cos x. Amen? Okay, we close the bracket. Then we have here 2 plus x squared. This is plus, all in brackets, 2 plus x squared. And what do we have here? Y. Note that our y has been given as x sine x. So instead of y here, we will substitute in this guy, x sine x. Do you agree with me? So we'll put it in brackets, x sine x. Amen? Equals to 0. Equals to 0. Do you agree with me? So now, let us look at the two brackets. Let us look at the brackets. Let's open the brackets. Whether at the end of the day, the left hand side will be 0 as the right hand side. Okay, so let's use x squared to multiply out this bracket. If you agree with me, definitely we are going to have x squared times 2 cos x. It will give you 2x squared cos x, amen. Then minus x squared times x sine x will give us x raised to the powers of 3. If you apply indices here, sine x. Amen. We are done with this bracket. Let's consider this bracket. We use minus 2x to multiply out this bracket. Do you understand? Are you following? Okay. So if you agree with me, minus 2x sine x, it will give us minus 2x sine x. Amen. Okay. So we will use this minus 2x to multiply plus x cos x. Minus 2x times x cos x will going to give us minus 2x squared cos x. Amen. Okay. Then we will use these two brackets to multiply out use 2 to multiply this, will give you 2 times this guy, will give you plus 2x sine x, amen? Okay, then we'll use x squared to multiply this guy. X squared times x sine x will give us plus x raised to the power of 3 sine x, which is equals to 0. Amen? Do you agree with me? Okay, so at this point, we collect like terms, or if you can see what I am saying without loss of generality. Okay, for the sake of maliance, is that clear? I'm going to break it down. Let me not just go straight so that you will understand it better. Is that clear? Okay, let's collect like terms. We know that this and this and this and this. Okay, let's do it this way for the sake of maliance. Amen. Okay, if you can see what I am saying, this and this. Amen. Okay, and this and this guy. Okay, do you agree with me? Then this and this guy. Do you understand? Okay, so if you agree with me, let's collect the like terms. Okay? Yes. We'll write this and this guy. It means 2x raised to the power of 2 plus x minus 2x raised to the power of 2 plus x. Amen? Then let's consider this guy and this guy. It means minus x raised to the power of 3 sine x plus x raised to the power of 3 sine x. Amen? Okay? Then we will consider this guy and this guy, and then minus 2x sine x plus 2x sine x equals to 0. Amen? Do you agree with me? Okay? I'm doing it for the sake of maliance. You know, after taking series of read, you'll find it difficult to understand. Is that clear? That is why I'm breaking down for you guys. Okay? So if you agree with me, without loss of generality, we know just like 1 minus 1 here. So it implies that this guy and this guy will cancel. Likewise, this guy and this guy will cancel. This guy and this guy will also cancel. It implies that 0 equals to 0. This is the answer. Is that clear? Any question? This is how to solve questions of this form. Amen.